Hi, welcome to everyone's favourite segment, the Mailbag. We'll get straight into it. First one here is from Chris Peters in Danville, California. There you go, in the United States of America. That crazy Aussie bloke, that's where you need to send stuff. And we have a t-shirt, pen and keychain. But it could be more interesting than that. It's got Maker Faire 2013 on it. So are these items from the Maker Faire, which of course I couldn't get to. Of course that would be the Bay Area Maker Faire, the biggie. Although the New York one's on very shortly, I think. And let's have a look. Cardboard stiffener. We have a letter. Well, look at that. What t-shirt have we got? I love shirts. Black. Alright, let's have a look. Oh, look, it's a mate. There you go. Oh, hang on. I haven't got a wide enough zoom on this thing. Maker 2013. Look at that. Beautiful. Is that the official Maker Faire t-shirt? Or I don't think so. It hasn't got Maker Faire on it. Oh, look. I've got a goodie bag. A candy necklace. Oh my goodness. I haven't seen those since I was a kid. A swirl pop. And keep calm and make on, Texas Instruments. Cool. So this is obviously the goodie bag. I don't know, did everyone get these when you went through the door? I'm not sure. Anyone who, well, I'm sure he'll tell us. I should read the letter, shouldn't I? I mean, this is ridiculous. Hi Dave, since you couldn't go to Maker Faire, I thought I would send some Maker Faire to you. Awesome, this was the first time he attended. I'm very surprised how big it was. 110,000 people over a 2-day period last year. So huge, so many different times, really difficult to describe. Yep, I know. Anyway, we've got the Maker Faire Sydney coming up on the 24th, the first ever Sydney Maker Faire. There's been one in Melbourne before and one in Adelaide, but not in Sydney, on the 24th of November. And I'll actually provide a link down below for submissions. If you want to get like a table or display anything or participate in Maker Faire Sydney, then the link will be down below. He made a point to find Jeff Kaiser, who, nice talking, signed his Maker Faire bag. Hi to Jeff. Hope you enjoy the t-shirt. My wife even added a lolly for you. I hope you enjoy it. Awesome. And Christopher is from faultlineaudio.net. Thanks very much, Chris. Got ourselves a Make keyring. I'm an inventor. Keep calm and make on Arduino. I have supplied a little button. I've got a Maker pen with a little ruler on it, inches and millimeters. That's surprising for you Yanks. And I've got Make special issue. Woohoo! Want to make a Tesla coil. I've never actually had Make magazine, so there you go. Arc Attack. Ooh, inside Maker Faire. Brilliant. 42 awesome projects. Definitely, there it is. There's the Maker Faire fold out. I'm definitely going to have to read that. Awesome. And it looks like we have a sticker pouch as well, like a whole swag of stickers. Goodness. Yeah. Wow. Arduino. Blah, blah, blah. Oh, Technical Illusions. There you go. There's Jerry. Projected AR game systems. Fantastic. And what on earth is that? It's a Fishmobile. Oh, goodness. Well, there you go. People who want to scan it, and you can check out the Fishmobile. The car has over 300 pounds of batteries, computer, 31 custom circuit boards, and 5 miles of control system wire, featuring 2 soloist conductors, 6 different singing, dancing, fish and lobsters performing opera to punk and rock. Check out the website. Oh, that's gold. It really is. So that is a huge swag. Thank you very much, Chris. Makes it feel like I went there. Awesome. I'll get there one day. Next up, we have a book from Kokomo Press in the US. And I haven't heard of Kokomo Press before, but I think I might know what book this is, if it's the one I'm thinking of. Let's find out. It was released at the Maker Faire. So let's have a look. Ta-da! It is going to be... Oh, come on. There we go. No, it's not the one I was thinking of. No wonder I haven't heard of Kokomo Press, because I thought it was the Maker book that I am in, which I will provide a link down below. There's an interview with me in the book along with Jerry Ellsworth and a whole bunch of other people in the community which you will know. So it's not that book. The Dog Barks When the Phone Rings, An Engineer's Guide to Solving Problems. More problems. There's our engineer, token engineer. Become a better problem solver. Look at this. This is fascinating. I never heard of this one. The transition from engineering school to real-world problem solver can be rough. Suddenly there is not just one correct response to a problem. There might be an infinite number of correct solutions where some are simply better than others. Some problems are so layered and twisted that the solutions seem absurdly complex. And it's written by Bob Schmidt, who is an electrical engineer with 4 decades experience in hardware, software and systems design with over a dozen patents. He has solved problems as an engineer, as a manager of global teams, as an entrepreneur. Ooh, that evil word. Bob also shares more parables for engineers at prettygoodproblemsolver.com. Good on you, Bob. And we've got a letter from Bob enclosed. Please find a copy of my book, The Dogs Bark When the Phone Rings, An Engineer's Guide to Solving Problems. This book is really intended for engineering students and recent graduates. Awesome! Your experience will probably make most of this book seem obvious, but maybe you will find a few laughs in there. I send this with full understanding that you're welcome to do anything you like with the book. I certainly will. Read it first, of course. Read it or not, comment or not, give it away, park it on a bookshelf, put it under a wobbly table leg, anything you like. I believe that my publisher has enabled distribution in Australia through Ingram, so this book should be available in Australia sometime in September. But is it available as an Amazon Kindle or other electronic download? That's what I want to know, because I'm a bit of a Kindle fan these days. Anyway, thank you very much, Bob, at prettygoodproblemsolver.com. And the first page I opened it up to talks about sensitive nodes. Awesome. Yeah, that sort of stuff, practical stuff, you don't learn. No, do I mean circuits or nodes that easily get their feelings hurt by criticism? Do I mean parts that intentionally respond to touch? No. There you go. How the heck do I know what a reasonable measurement is? This sounds really quite neat. Teardowns as a debugging tool. There you go. Fantastic. C problems. Teardown exercise let you remeasure the performance individual component. It's all in here. Instrumenting software. Let's go to the index. Here we go. Dave, best wishes for your continued success. Thank you very much, Bob. Bob's your uncle. Bob is my uncle, but not this Bob. And there's our index. Looks quite good. Barriers to good. It's all about communication. Communicating clearly. What don't you know? Everything when you leave school. That's for sure. Finding the stuff you don't know. Experiments debugged by division. Stimulus response testing. Oh, excellent. If I could see it, I could fix it. Measurements. Instrument software. Tools. Intermittent problems. Oh, they're a bastard. Nothing like an intermittent problem and a good red herring to go with it. How to think, part 1, pretty important. How to think, part 2, it was so important you added 2 parts. The great idea does not have to work to be a great idea. Very true. Study your mistakes. Yes, fail is, learning is all about failing. So there you go, 243 pages. Excellent. What's the index like? It's pretty sparse. Pretty sparse, but anyway, this is a book that you just read from cover to cover. You don't sort of, reference individual bits. Oh, where's noise floor? You're not going to look up noise floor, perhaps. So it seems like a more conversational style book that something like I would write. So yeah, I'm definitely going to enjoy giving this one a read. Dead trees. Love it. I like this little bit. Here is one of the most important things I can teach you. There is a giant difference between customers and investors. If you do most things right, a customer will not want his money back, his or her money back. In fact, the better you do things, the more likely a customer will give you more money. Of course they will. In contrast, even if you do everything right, an investor wants all of their money back. All of it? No, all of it times 100. Whoa, clear enough. Got it right, Bob. Next up, we've had one I've had sitting around for quite some time from Worth Electronics, and it is a energy harvesting kit to go. So beautiful. I do like energy harvesting. So I do have an energy harvesting kit. So I can't remember who it's from. I'm pretty sure it's not this one. And I've had that for I don't know, four years or something. I had it for quite a long time, so I may have to. Oh, this one. Oh, linear technology. We're energy micro. Ah, man, this one is serious. Look at this. From Worth Electronic. Design kit, energy harvesting solution to go. Linear technology, energy micro. It's got a whole bunch of stuff. Complete solutions for harvesting energy, energy management, storage. Blah, 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 blah. There's the order code if you want to check it out. IC744885. I'll provide a link, as I do, to all stuff. And this looks, whoa, comprehensive. Look at this. We've got a Peltier. Check it out. Which can, and we've got a another giant gecko. Fantastic. Can always do with a giant gecko. We've seen that featured on the blog before. That is an excellent little board. I like it as part of the watch thing that I did a while ago. Anyway, the sharp low power LCD display. Got ourselves a solar cell, and what do we hook onto there? Is that a piezo? Power, I don't know. Demo circuit board, multi-source board. So converting thermal energy into power. That's basically what we're doing there. So with that Peltier device on the heatsink stuck onto the board there. So we're going to have to check out what energy harvesting chips actually used on this. I tell you what, they've gilded the lily on this case. I mean, look at that's just sex on a stick. Look at that custom foam insert. Oh man, jeez, they really have gone to town there. And I just love the smell of this rubber. Oh yeah, it smells like a pair of thongs. Whoa, look, I didn't do anything, and my board, my giant gecko board, just sprung to life. There we go. And I don't know, what's that Fahrenheit? That's temperature, and that's Fahrenheit, and 22.2 degrees C. It's jumping around a bit, but there you go. It's obviously getting power from is it getting power from the solar cell or from the thermal, or both, perhaps multiple sources? I guess that's the idea that they want to demo here, and I haven't actually looked at it yet, but we're looking. It looks like we've got different energy harvesting chips. This is really quite neat. It looks like you can evaluate the different types. Oh, beautiful. But by default, I didn't touch anything, and it just sprang to life. Fantastic. And I'm covering that solar cell, and it's slowly dying. You can still, it's just hanging in there. Still just got enough power, so clearly it's getting most of that, or all of that, from the solar cell. Hasn't sprung back yet. But anyway, we can still operate this thing. This switches between, I mean, that LCD is getting pretty dim there, but it's still operating, so we can switch between Fahrenheit and Celsius as the main display there. Excellent. And what we've got is 4 different energy source circuits here. You can set using this particular jumper here. One's for the supplied solar cell, one's for a diode voltage drop or solar cell. The other is the TEG powered energy harvester, which is TEG stands for thermoelectric generator, which is of course the Peltier device up there on the heatsink. And then we've got a piezoelectric energy harvester, which can hook up to an external piezoelectric element. It's not on board, but that's what that connector up there is. You just connect in your particular piezo thing, shock, vibration, all that sort of stuff, or if you're walking or something like that, you can generate tiny amounts of power, and this is what energy harvesting is all about. And in this case, they've got some storage caps on the back, just some very high value ceramic SMD caps on there, just to store a bit of energy. But there you go, that is rather neat. And the documentation here, which I will provide a link to this website, but as you can see, these are the different devices. LTC3105 for the solar cell. It tells you all about the micropower monolithic booster. We've got the Peltier element and what LTC parts, the piezo element, they're all LTC energy harvesting chips, but there's an inductive energy harvester. Fantastic. So there you go. This is a really nice little starter kit for energy harvesting. It really is fantastic. I like it. And I just checked the price, and yep, it's not cheap, folks. 199 euros. But, you know, I mean, it's all there. All the different types of energy harvesting. So if you're really serious about experimenting, then it's worth every cent. I mean, the giant gecko board alone is worth about 80 US bucks or something like that. By the way, Energy Micro were bought out by Silicon Labs, so they're no longer Energy Micro. Oh, boo-hoo! We've had them on the amp hour. So this kit craps all over the other energy harvesting kit I've got, which is, you know, just got one particular type, pretty ordinary, I think. But yeah, I'm definitely going to have to do some videos on energy harvesting. And, well, if you want energy harvesting videos, please leave it in the comments. Let me know and encourage me to actually get off my ass and do some energy harvesting videos, because there's some great, you know, really low power measurement stuff you can do with these energy kits, which, you know, I really can't get into doing that sort of stuff in a mailbag. It'll take me quite some time to set up those things and perform the experiments. And of course, Worth Electronics aren't shy about telling you what parts on all this system are theirs. Look at this. They got the USB connector, of course, the battery holder. They got the caps. They got, looks like, what's that, a little LED or something. And they got the switches, and they got the inductors, and they got the connectors over here, and the pots, and man, the connector. Caps, they do everything. So thank you very much, Worth Electronics. That is an awesome energy harvesting kit. I don't think you can do much better than that. Now, of all the linear technology chips used on this thing, the most interesting by far is the LTC 3588. The other ones are just basically just run-of-the-mill, well, not run-of-the-mill, but, you know, pretty good low power, low voltage boost converters. That's pretty much all they are. Like the one for the solar cell, for example, is just your average boost converter. But this 3588 is quite a useful energy harvesting device. And let's actually take a look at the thing here. It's specific. This is for the piezoelectric energy input from that terminal, because we don't have a piezoelectric element on the board. We have to add that separately, but it can do not only piezoelectric but other sources as well. So let's take a look at it. Quick look: 950 nanoamps quiescent current. Output it with no load on the thing. 450 nanoamps input quiescent current in ultra low voltage lockout mode. 2.7 to 20 volt input operating range. So this one specifically doesn't go down to low voltages, but as we'll see, it allows us to do quite a few useful things. And it's got an integrated full wave bridge rectifier in it, hence the ability to rectify the AC coming from a piezoelectric element. And it's pretty beefy, up to 100 milliamps of output current. Of course, in piezoelectric mode, you're usually not going to be able to generate that kind of stuff, but it's a generically useful chip, and you can select the output voltages, all of you know, 1.8, 2.5, 3.3, 3.6. Very nice. And of course, it has a high efficiency buck DC to DC converter in it. It's got input protection and under voltage lockout. Unfortunately, it comes in a pain in the ass 10 lead DFN package. Evil. But anyway, this is how simple it is. Here's your piezoelectric element here. Hook it up to the 2 pins, nothing else required, and just a couple of caps here and an output inductor, and that's it. And the output capacitor here, this 47 microfarad 6 volt, of course, that can be like that whole storage array you saw there before of all those chips. I'm not sure what values they were, probably like 100 microfarads each or something at 6 volts. Or you could use a super cap, for example, there. And let's go down and have a look at some of the useful applications. We won't worry about the graphs and stuff like that, but here's the full wave bridge rectifier, basically. So it's just a bridge rectifier with a separate input voltage, so you can actually use it as like a dual source converter there, and just digital control to set your output voltage. So nothing too fancy, but what that allows you to do is, if we go down the bottom here, here it is. Here's our just a regular piezoelectric one, as we saw before. Nothing much doing there, but then we get into some of the other applications. Look at this. This is a dual rail generator, so you can share
the same piezoelectric element, of course, just in parallel across both chips. So you can generate a 3.6 volt rail, for example, and a 1.8 volt rail shown there. And then this is an example of the dual source with energy harvesting with battery backup. So we've got our external 9 volt battery there. You need a reverse protection diode, of course, otherwise, because as we saw in the internal diagram up here, where is it? Here we go. There is nothing stopping the piezoelectric element reverse charging your battery on your V-in over here. So you obviously have to put that series diode in for any external power source. And down here, this is quite neat. Look at this. Danger, Will Robinson. High voltage, you can actually just hook it up directly to the mains like that with a couple of series resistors. And because it's just a full wave bridge rectifier, then you can just use it as a non-isolated, of course. That's why they put all of the, danger, use isolated isolation transformer when testing, blah, blah, blah. So it's not an isolated mains isolated one. So just be careful with that. But that is quite neat and accepts, I'm not sure what frequency range it accepts over, but apparently it is quite broad, of course. And this one is quite neat, electric field energy harvester. Look at this, it's just telling you, basically, just to get 2 copper panels there and just place them 6 inches away from a fluorescent light fixture, and that's going to generate enough power to, charge up your supercap or charge up your lithium-ion battery or do whatever you want to do. And here's an example with a supercap, of course, it being used with a solar panel here, so you can actually feed the solar panel via a series resistor into one pin of the piezoelectric element, because it's just a diode bridge, of course. You can feed DC into there as well. And then you get your output voltage, and the supercap, of course, stores everything, because you don't need any reverse diode on there, because that's, or series diode in there to prevent back discharge into the chip, because the chip just shuts down when it does that for you effectively. It just shuts down when there's not enough input voltage to charge the supercap. So your supercap can then continue to charge all your circuitry while this chip shuts down if your light goes away, for example, with your solar cell. And then once again, you can hook this up to the thermoelectric generator. So this is a pretty versatile chip. It accepts, with that diode bridge in there, accepts pretty much any source you want to throw at it. I really like this thing. It's a shame it's not in a nice SO8 package or something like that. Would have been nice, but anyway, I like it.
And we've got another one here from Jameco Electronics, who had a couple of sucks of the sav on the mailbag here. So let's pop it open. It's Opto Electronics. What does that mean? I don't know. Obviously a kit. Jameco do kits, so I think I've got a couple of previous ones I still haven't assembled. I'm going to do that one day. A lot of people keep asking for, can I do like kit assembly videos with all the kits I've got? Oh, well, maybe, but what do I do? What's so excited about, seeing me assemble kits, I guess, not very exciting at all, I suspect. No, hang on, I'm going to just slice this buggery out of this thing. And it's obvious when you know how the end just pops off. It comes electronic do-it-yourself and components. Check this out once again. Nice little jazzy case. Hi Dave, thanks so much for requesting our Skyrider kit. Oh, did I? Please let me know if you have any questions. Look forward to hearing from you. Thank you very much. Francis, it's one of those wands, by the way, that you just hold. It's got a microcontroller on it. These were all the rage years ago. They're still quite fun. I highly recommend it's a good beginner kit, and you can experiment with firmware. So it's basically just a microcontroller. What's this one, a PIC or an Atmel or whatever, and you basically got some LEDs on there, and you put them on, and you wave it like that, and you can get a message on via persistence of vision. And the good thing about this kit is that it's all through-hole. There we go. They even give you a proper socket, through-hole LEDs, individual resistors, all in individual little baggies like that. Fantastic. And a battery holder. How do you get a 3? How do you stick the battery? I guess you sort of, oh yeah, it comes, you know, and then it makes it into a grip like that. That's all right. Nothing wrong with that. Probably don't have a voltage regulator. They probably just run it off the 3 AAA cells or whatever. But yeah, I mean, this is one of the things, right? You know, people ask, oh, why don't you do SMD kits? And well, you know, this is dropped it. This is the reason, because it's bad enough with through hole. You know, you've got to bag individual resistors and individual caps and stuff like that. Imagine a complex kit with all SMD parts, which basically don't have any labeling on them, and you've got to cut them off the individual strips, and it's just far too hard. Don't even want to think about it. And they've got reasonably detailed beginner instructions here with you know, step-by-step photos. I mean, you know, if you're relatively well, if you've built a couple of kits, you're just going to hoe straight into this thing and get the sucker working. Yeah, pick this out. 16C84 classic. It's not even the F84, it's the old C84. This must be a quite an old kit then to use the C84. Anyway, there you go. I'll provide a link down below if you want one of these Skyriders. They are quite fun. Not sure of the price, but it'll be linked in down below. You can get it from Jameco.